Electricity is becoming more and more common in our daily lives. Just like mobile phones, air conditioners, and many more daily electrical appliances, electricity is commonly known as an energy source. But what exactly is electricity? And how exactly will electricity related to magnetism? In this video, we will cover the basics of electrostatic force, electricity, and magnetism. So what is electrostatic force? In an atom, there are three different subatomic particles: protons, electrons, and neutrons. Protons are positively charged, and electrons are negatively charged. So when an object is positive, it has more protons than electrons. If an object is negatively charged, that means that object has more electrons than neutrons. So when a positively charged particle meets a negatively charged particle, there will be attractive force between them. When the atoms of the same charge meet, there will be repulsive force between them. The magnitude of electrostatic force of attraction or repulsion between two charged atoms is directly proportional to the product of magnitudes of charges and inversely proportional to the square of the distance between them. Coulomb's law is used to calculate the electrostatic force between two objects. In daily life, the phenomenon of electrostatic force is very common. For example, rubbing a glass rod with a piece of fur. Through the process of friction, the glass rod gains positive charge from the fur, which will repel objects such as tinsel, which is also positively charged. Each charged particle has an electric field. Within the electric field, there will be attractive or repulsive force with another charged object. The electrical potential of an object is the amount of work needed to move a unit positive charge from a reference point to a specific point inside the field without producing any acceleration. The electrical potential of an object is affected by its materials. For electrical appliances to work, an electrical circuit must be present. But what is an electrical circuit? An electrical circuit is the flow of electrical charge. This charge is carried by moving electrons in a wire. The direction of an electrical current is by convention the direction in which a positive charge would move. Look at the light bulbs in your flat. Have you ever wondered how electricity could generate light? Electrical energy can be transformed into light energy in an electrical circuit if a light bulb is added to the circuit. In an experiment, this transformation may be that of the chemical energy in a battery is transformed into electrical energy in the circuit, which is transformed into light energy and heat energy in the light bulb. Ohm's law is important in electricity. It deals with the relationship between voltage and currents in an ideal conductor. This relationship states the potential difference in voltage across an ideal conductor is proportional to the currents through it. It's given by V equals IR, where V is the potential difference, R is the resistance, and I is the current flowing through the resistance. To calculate the resistance, you need to divide the voltage with current. Now you may be asking, what factor affects the resistance? The material, length, thickness, and temperature affect the resistance. Have you noticed your electrical appliance becoming hot? This is because when a current passes through a conductor, there is a heating effect. This effect is used in fuses. There is a very thin metal wire going through it. When the current becomes too strong, the wire becomes extremely hot and will melt. As a result, the circuit will be severed and no electrical current will flow. This can prevent the electrical device from being damaged by the heat generated from the current. Our Earth is protected from ultraviolet radiation by our magnetic field. In this magnetic field, there is a north magnetic pole and south magnetic pole. These two poles repel each other. Earth's magnetic pole is generated by the electrical currents in the conductive material in its core, which is created by convection currents due to heat escaping from the core. Compasses rely on this magnetic field to work. The compass needle is attracted to the poles, which will turn as you move around. This invention has helped many people to travel and to find their way when they are lost. Electrical currents have two types: direct currents and alternating currents. In a direct current, the electric charge only flows in one direction. In an alternating current, the electric charge changes direction periodically. The advantages of transmission of electrical energy with alternate currents at high voltage is that it minimizes the power loss due to resistance in conductors. Also, high voltage is needed in the power lines, as high voltages can increase the efficiency of transmitting energy through the power lines by decreasing the heat loss in the power lines. However, lower voltage is needed when using the electricity, as high voltage will kill people. These are the basic concepts of the units electricity and magnetism. I hope you have learned more about this unit and now understand how and why electrical devices or appliances work now.